I'm going to demonstrate how we use actual circuit items to find the resistance of some unknown resistor. The resistor we're going to use is color-coded brown, green, brown. So how many ohms is a brown, green, brown resistor? Well, to find out its resistance, we have to get the ratio of the potential difference or voltage across the resistor and divide that by the current that goes through the resistor. And when we take the volts across it divided by the amps through it, we get the resistance. So we're going to use a power supply of 6 dry cells connected in series. And you remember, one dry cell is about 1.5 volts. 2 of them would be 3 volts, 4.5, 6, 7.5, and approximately 9 volts for 6 of them. We'll use 2 multimeters, one set to potential difference or voltage, which will be connected across the resistor. The other is set to current, measured in milliamps, and it'll be connected in line with the resistor. So we'll start out by going from the power supply to a switch. From the switch, we can go to our resistor. From the resistor, we go to our ammeter. And then from the ammeter, we can go back to our power supply. I'll throw in one more alligator clip wire. These meters time out and make a loud noise when they're timing out and you have to restart them. So I've got a complete circuit from power supply through the switch, through the resistor, through the ammeter, and then from the ammeter back to the power supply. When I close the switch, I get a reading of about 8.01 or 2. I don't know why it was beeping again. 8.07 milliamps. But I don't have a voltage yet because I haven't connected the voltmeter to the resistor. So I'm just going to put it on one side and then the other. And it's reading about 1.21 volts. This battery must be getting kind of weak. If I take that 1.21 volts and divide it by 0.0082 amps, I get 147.6 ohms. Remember that, 147. Now I'm going to move over and run it with 2 dry cells. I now have 2.69, 2.70 volts divided by my milliamps of current, which will be 0.0182 amps. And when I divide those, I get 148.4 ohms. So we got 147, 148. We can do it for a third trial. 3 power supplies gives me 4.17 volts. The current is now 0.028 amps. That's 148.9 ohms for the resistor. I do another trial. 5.71 volts divided by 0.0387 amps, and that gives me 147.5 ohms. 147, 148, 149, 147. Notice a pattern. We go up again, 7.15 volts, 0.0485 amps, gives me 147 ohms. And the last, at full power, 8.56 volts divided by 0.0582 amps gives me 147 ohms. So we're getting anywhere between 147 and 149 ohms regardless of what we're powering the resistor with. This green-brown resistor is actually 150 ohms. So our value on average is in the 148 ohm range, which is very close to the 150 ohm value. In fact, when you buy these resistors, they come with a tolerance of, this one is 5%, so any value we get within 5% of the 150 ohms that the brown color code tells us would be considered perfect. And the 148 ohms that we're getting is definitely within 5% of the 150 ohm value. Because the resistance of this resistor stayed constant, no matter what the power supply was, put more volts on it, we get more current, but the ratio, potential difference by current, is constant, we say this resistor obeys Ohm's law. Ohm's law states the resistance of a resistor remains constant. So the resistance didn't change. Not all resistors follow Ohm's law. We have resistors that are considered non-ohmic. Generally, resistors that don't obey Ohm's law, their resistance goes up when the temperature goes up. The hotter the resistor, the greater the resistance. If this resistor did not obey Ohm's law, if it was non-ohmic, as I gave it more power, that would heat it up and the resistance would go up. We might have started with 150, and by the time we got all of them, we might have had 200 or 300 ohms. Light bulbs that get hot do not follow Ohm's law. Other elements, circuit elements, generally do follow Ohm's law, provided they don't heat up. So what I've just done is demonstrated a very common experiment for measuring the resistance of an unknown resistor and seeing if they obey Ohm's law.